Sorry, students, our last section remains incomplete due to some problem. Now we are going to discuss again that section. So, at last, we have completed that we have to repeat this experiment so many times. We can repeat this experiment by changing this knob, by changing the knob of this rheostat, so that at so many times the value of current increases, and we are measuring the ratios, we are measuring the values of potential difference across voltmeter and current flowing through a conductor that we will measure across ammeter, and we are representing these values in serial number accordingly 1 2 3 4 5. For example, we are going to start this experiment. We are closing the key and we are measuring both voltmeter and ammeter. We are taking the readings from voltmeter and ammeter. Suppose the voltmeter reading is 5 volt, that means we have applied a potential of 5 volt. Suppose at that potential of 5 volt, current flowing through this circuit, current flowing through this conducting wire PQ, is 2 milliampere current. We can measure because this ammeter has a very small range, that is it is measuring the current in milliamperes, and voltmeter measures the potential difference in voltmeter. Suppose in first reading voltmeter reading is 5 volt, at that time current is 2 milliampere. So we can calculate resistance that we have already discussed in the last session. R is given by the ratio of potential difference with respect to current, and that is, suppose it is 5 volt with respect to current we have represented. Suppose we have measured the current 2 milliampere, then it is equal to 5 volt divided by 2. Milli means 10 raised power minus 3, because 1 milliampere is equal to 10 raised power minus 3 ampere. So 2 milliampere means 2 into 10 raised power minus 3 ampere. So it becomes 5 volt. 5 divided by 2, that is equal to 2.5. 5 divided by 2, that is equal to 2.5, divided by 10 raised power minus 3. Then it is volt, it is now ampere, then it is equal to 2.5 into 10 raised power minus 2, reciprocal becomes 10 raised power 2. 10 raised power 2 volt by ampere, it is known as ohm. So the resistance of this wire PQ at that time, it is equal to 2.5 ohm. Now in second case, suppose potential difference, we are applying 10 volt. At 10 volt potential difference, current flowing through a conductor is 4 milliampere. Then again we will calculate the value of R, that we will solve here. R is equal to, instead of 5 volt, now it is 10 volt divided by 4 milliampere. Then it is equal to 10 volt divided by, instead of 4 milliampere we can write 4 into 10 raised power minus 3 ampere. Then again it will becomes 10 divided by 4, I think that is equal to again 2.5 into 10 raised power minus 3, उसको हम ऊपर लेंगे, then it is equal to 10 raised power 3 volt by ampere. Again it is ohm. So again resistance of the conductor is 2.5 ohm. As in the first case it is 2.5 into 10 raised power 3 ohm, and in the second case it is 2.5 into 10 raised power 3 ohm. Now similarly in third case, suppose our voltmeter reading is 15 volt and current flowing through a conductor is 5 milliampere, and again we are calculating the value of R, that is equal to, now instead of 10 it is now 15 volt divided by, it is now 4, instead of 4 it is now 6 into 10 raised power minus 3 ampere. Then again I think 15 divided by 6, again that is equal to 2.5 into, इसको फिर से 10 raised power minus 3 becomes 10 raised power positive 3, again volt by ampere, that is known as ohm. So again resistance of the conductor becomes, so here we write 2.5 into 10 raised power 3 ohm. Again R is equal to 2.5 into 10 raised power 3 ohm. Similarly for fourth one we will take 20 volt, and for 20 volt suppose it is 8 milliampere current, then again we will calculate its value, that is equal to 2.5 into 10 raised power 3 ohm. We will calculate its value in the same way, that is R is equal to V upon I, that is equal to 20 divided by 8 into 10 raised power minus 3, it is volt divided by ampere, and volt by ampere it is again ohm. 20 divided by 8, I think again it is equal to 2.5 into 10 raised power 3. So again resistance. So in all the four cases, now what is the conclusion? In all the four cases we we have shown that resistance of a conductor in all the four cases remains constant. So earlier we have discussed that ratio of V divided by I, that is equal to R, and R we have given the name that it is a constant of proportionality. That constant of proportionality is known as resistance, and that is why here we have calculated its value, it remains constant. So finally we can say the conclusion from this graph that we have plotted, we conclude that I is directly proportional to V. When R is constant, we can say, when R is constant, we can say V is equal to Ri. So is equal to R, we can say it is directly proportional to I. So finally we have concluded that R, it is ratio of potential difference with respect to current flowing through a conductor, but this ratio always remains constant, which proves Ohm's law. And also remember this thing, if we plot a graph between this potential difference that we have calculated along x-axis we will plot, and along y-axis we will plot current, so it is a graphical variation between potential difference with respect to current. When we are substituting, when we are taking these values, suppose here we can draw particular points with the representing 1 volt, 2 volt, yeah, or we can say representing 5 volt, 5 divisions we can take 10 volt, 15 volt, 20 volt. Similarly here we represent 2 milliampere, 4 milliampere. Similarly we can represent 6 milliampere. Similarly we can represent 8 milliampere, and we will draw these points that we have calculated and listed in the table. When we will denote these points, when we will represent these points in the graph, and we find the graph looked a straight line, we obtain a straight line. That straight line indicates that R remains constant, and this variation between V and I is the graphical variation of Ohm's law. Also remember this thing, I have written here some important key points. Ohm's law is valid only if the temperature remains constant. The first thing, temperature should be constant, then at that time we can say I is directly proportional to V. We can say I is directly proportional to V, but condition is at constant temperature, at constant temperature. Now number second thing is that bigger units of resistance, we have shown that we already, I told you, resistance, unit of resistance is ohm, unit of resistance is ohm. But if we talk about bigger units, if we are measuring the resistance in bigger units, then bigger units is kilo ohm. 1 kilo ohm, 1 kilo ohm, remember 1 kilo ohm, kilo means it is equal to 10 raised power 1000 ohm, or 10 raised power 3 ohm, sorry, or we can say it is equal to 1000 ohm. So 1 kilo ohm we can say it is equal to 1000 ohm. And similarly another bigger unit of resistance is mega ohm, and 1 mega ohm, that is equal to 10 raised power 6 ohm. These are the bigger units of resistance. So we have completed our topic, that is Ohm's law and its experimental verification. Okay.